Hi, welcome to the 2.4 video. I didn't finish continuous random variables in class. So imagine this is what we would be doing in class on Friday. And definitely come to see me if anything that I do on this doesn't make sense. Yeah, it's kind of a nice way sometimes to explain things. And, it's kind of like watching TV maybe, but not as exciting. If my dog starts barking, that's because there's a bunny that sits in the front yard that drives her nuts. And it always comes back to the same place, so every few hours I have to get up and go chase the bunny away or she just goes nuts. So anyway, we're in 2.4. This is page 41, but we had gotten through discussing discrete. We had some examples. We did examples in class with discrete random variables. We had just started continuous, so we discussed this example with sleep hours. We put a continuous function to it. I showed you that we integrated to find probabilities. And we had stopped here at this example. So this is page 47, and this was just another continuous example. The time, headway, and traffic flow. So what I'm actually looking at is the time between when one car passes a certain spot and the other. There's amount of time between when this car passed that sign and this car. Maybe it's t equals, I don't know, 1.2 seconds or something like that. But so that's what this random variable is. And actually here I called the random variable capital X. So this is the probability distribution that finds the probability of the time between these cars being anywhere, greater than 0.5 seconds. This starts at 0.5 right here, which is good because if it was 0, that would mean two cars are tailgating. So from this function, you could say, what's the probability between this car passing and the next car passing is more than 4 seconds. So more than 4 seconds, this is the graph of f of x here. So I'm just finding the area under the curve from 4 to infinity. So again, with a continuous function to find probabilities, you're just integrating. So before I even use that function, sometimes we like to check a few things. Is f of x a legitimate probability density function? And so here's the function, and we said yes, and I believe I checked right here. F of x is always bigger than or equal to 0, meaning it's above the x-axis. And the other thing I'm checking is that when I integrate from over the bounds where this guy is defined from 0.5 to infinity, that he integrates to 1. And, if it's a function like this, we're allowed to use Maple in this class, so we can stick this in, integrate, make sure it integrates to 1 over that support. So below, I just did it by hand, but all I'm showing here is if I integrated f of x from 0.5 to infinity, I got 1. So I'm just doing the serious integrating and showing you that it's nothing you haven't seen before. So it does integrate and gives you 1. Now to find probabilities, I just integrate over different intervals. So determine the proportion of cars, the time between them is at most 5 seconds. So back there on that curve, I'm going to integrate. So remember the curve looked like this, and it started at 0.5. So at most 5 seconds, here's 5 seconds, and here's 0.05, and I'm just going to integrate to find the area between that. So that's what I'm doing right here in this integral, and I get a value. Last question, determine the proportion of cars in which headway time between them is exactly 2 seconds. So probability x is equal to 2. But remember, this is a continuous random variable, so we want to find the area under the curve under 2. So 2 to 2 of any f of x dx is going to be 0. So there's no area at a point, so there's no probability in hitting exactly a given point on a continuous distribution. So I'm just showing, similar to discrete distributions, we have formulas for the mean and variance. Oh, here's mean and here's variance of a continuous random variable. So for discrete, remember we said we're just taking a weighted average of our x values, so x times p of x, where the p of x is the weighting function. So same thing over here, it's x times f of x, where f of x is your weighting function. The difference is I'm not going to be summing anymore, but I have the integral. So I'm going to integrate over my support, x times f of x. And for the variance, I also have integral of x minus mu squared times f of x dx. Actually, remember in the last, for discrete, we simplified that. We said that's the same thing as the support of x, and we can say x squared times f of x. And then after we compute that, we're going to subtract off the mean squared. So I still prefer this for the variance. They're exactly the same formula, except all I've done is multiply this out and found an identical formula for it. Standard deviation then is the positive square root of the variance. Also here for continuous, we talk about the median. So the median of a continuous random variable, let me draw a graph like that first one, the headway time. So here's 0.5. What you mean by median is you're trying to find that value somewhere in your support. Let's say maybe it's right here, m, such that 50% of the area is on each side of the median. So basically all you're doing is you're setting up an integral with m, and you're trying to find m such that half the area is to the left and half the area is to the right. So I have an example, a couple of examples I thought we would go through, well, two of them. Well, this one's already done for us. This again was back to the headway time between a car passing and the next car passing. Here I asked you to find what's the expected value, or the average time, or the mean, and what's the standard deviation. So I typed in f of x here. I used command line. I integrated over the support to show you get 1. And then I found the mean, which is just f of x times x. So here is f of x times x over the support. And then this is the mean of that random variable. That's the expected time between two cars on average, about 7.2 seconds. And okay, I kind of made this messy. Here's the variance, and then I'm taking square root to get standard deviation. But here I have f times x minus mu squared, and I didn't use the shortcut formula here. If I had used the shortcut formula, I would have integrated f of x times x squared from x equal 0.5 to infinity. And then I would have subtracted off mu squared and got the same answer. And so by taking the square root, then we get the standard deviation. So I put an example on here. I think we have time for one or two before this gets too long. So we'll start brand new. So I have a function, f of x, and it's defined for x's between 0 and 2, and I want to find its mean, its standard deviation, its median. First, I'm just going to see if it's valid. So let's graph this guy. So he's defined over 0, 1, 2. So 0, 1, 2, here's my x's. And then my y's, let's just let this be a half and 1. So here's 1/2 and here's 1. So when x is equal to 1, this is equal to 1/2. And when x is 2, f of x is 1. So here's my function, right, f of x. So f of x equals x over 2. Okay, is it valid? Probably the easiest way to tell is just look at the area. So area of that triangle is 1/2 times the length of the base is 2 times the height of that function is 1, so that's 1. So yeah, he's always above the x-axis and he integrates to 1, so he's legal. Okay, so there was the graph. Now I want to find his mean. I'm trying to find that point in here that balances, the weight. So by definition, this is just the integral over the support, 0 to 2, x over 2 times x dx. Okay, so this is just 0 to 2, x squared over 2 dx. So this is going to be x cubed over 6, right, from 0 to 2. And so we put that in, that'll be 8 over 6. So that is our mean, 4/3 or 8 over 6, and we're done. So if you go to 4/3, the mean is just about right here, that balancing, the weight, the balancing point. So sigma, I'm going to find sigma squared first. So this is just going to be 0 to 2, x over 2 times x squared dx. And then whatever I get for this, I'm going to subtract off mu squared. So I actually already did this. I integrated this part here and I got 2. And then this part here is just 4/3 squared. And so let me see. I got this, if I'm thinking right, I got this to be 2/9. So this came out to be 2/9 for the variance, which means then the standard deviation is just going to be the square root of 2/3 since it's the square root. Okay, so there's that. And the median is not the mean. So the median is that point. So let's draw this picture in here. The median is going to be that there's some m in here, right? That leaves 50% of the area. Obviously, I don't have the right picture. 50% to the left, sorry, and 50% to the right. So I'll just set up the integral. I don't know where my page just went. Let's go back up there. So I'm just going to set up the integral I would use to find m. Hardly any space left. Okay, so I'm going to integrate from 0 to m of x over 2 dx. I want to find m such that half the area is up to m. So there's my expression, and I would just solve that guy for m, and I have my median. In fact, I already did. I solved for it before I made this video, the messiest one I've ever done, and I got m equals the square root of 2. Okay, so there's that example. I thought I'd do one more with the exponential, and then I'll leave 10 for you. I don't know if you've noticed how these fit, but these fit exactly. Let me switch over to the quiz. So here's the quiz, quiz 3A. This goes along exactly. Oh, I forgot I'm not in annotator. So quiz 3A goes along exactly with the lecture notes I'm going through. So I've already done for you problems 1 and 2, right? We have the function. I found the mean, the standard deviation. I'm giving you a chance to go ahead and do it on your own if you want to check. So I'm going to do right now on the slide. I'm going to do number 3. So if you don't want me to spoil the magic for you, if you want to go ahead and do it first and then check my answer, I'll leave 4 and 5 for you to do. So that's the next example. But I'll go back to the worksheet and go through example 9. So here is example 9. Back up here. So the length of a phone call has the following distribution, 1/10 e to the negative x over 10. So again, I know what that looks like. This is just an exponential function. Looks like that, right? Here's my x's. This crosses up here at 1/10. So this is the graph of f of x here, and there's x. So there's the graph. It's always positive, and I can assure you it always integrates to 1. I've already checked. What proportion of phone calls made in the U.S. lasts more than 10 minutes? So wherever 10 minutes here, let's just put in 10 minutes here. More than 10 minutes is just the area under the curve after 10. So let me just set up the integral for you then. I'm just going to integrate from 10 to infinity, 1/10 e to the negative x over 10 dx. And I actually have already done it. Let me turn the page here. I did it by hand, and then I put it in Maple, but you'll get e to the negative 1. You'll get exactly e to the negative 1, which is approximately 0.3679. What's the probability that phone calls are last between 10 and 20 minutes? So now I'm just putting the upper value on this integral. So 10 to 20 minutes would just be, right, just a little chunk of it. So again, the integral is pretty nice. 10 to 20, 1/10 e to the negative x over 10 dx. And for this, I get approximately 0.2326. Last, I'm trying to find the value c such that 90% of calls are bigger than c. So let's just draw on this graph again. So here's the graph of f of x, and I'm trying to find this value c such that 90% of calls are bigger than c. So that also lets me know that 10% is less than c. So I'm going to set up the following integral to find c. I just want to find the value c such that when I integrate f of x, the area under the curve up till c is equal to 0.1. And so then I'm just going to solve that for C. Again, this is not a hard function to integrate. You could do it by hand or stick it in Maple. I did get a C, but of course, oh yes, I did find it. Here's C. C should be approximately 1.054 minutes when I found the value of it. Okay, so I just didn't want to get this too long, and I'll go on to making a video about the normal. I'm leaving 10 open, that's on the quiz, but I think you'll get an idea from the last two examples how to set it up. If you have any questions, just let me know, and there's always PSA. And if I don't talk to you tomorrow, have a good break. Enjoy that 2 weeks, huh? Okay, more soon.